Alright, so what I have here, this is for my students who need help with Excel and programming a little bit in Excel, or any Excel knockoff. So I am doing this with Google Sheets and should translate to just about any flavor of Excel and its knockoffs. So let's see here. So the problem that I have proposed to myself, I have a parachuter who's going to jump out of an airplane at 2 kilometers up, and they're going to deploy their parachute at 500 meters. They have a coefficient of drag of sigma 1 with the undeployed parachute, and when they deploy their parachute, it becomes sigma 2. I want to know when do they land and how fast are they going when they do it. I have left these as variables in my problem statement because I'm not really sure how big I should make them. So I need to come over here and make times down. So I have time, position, speed, let's see here, and we need the forces on them, and then acceleration, and then we're going to use the stuff we have learned in class to solve this problem. I am declaring that I am, so normally there's a whole lot of stuff that goes into what the force of drag is. The force of drag is equal to sigma times, is equal to minus sigma times velocity as far as we are concerned for today's exercise. There's variations of this for other reasons. Alright, so time step 0, they are 2,000 meters up, they have a speed of nothing, and the forces upon them, we are going to have just gravity right here. So that's going to be 9.8 times, I need their mass. We'll come by that shortly, won't we? Insert a row above so I can note their mass. What is it? Time. We mash our buttons right. Time. There we go. Mass. We'll go 100 kilos because that's about where I'm at. 100 kilos. Oops. Kilograms goes there. A 100 kilogram. There we go. A little more complete information there. Alright, forces. There we go. So in this particular case, we have 9.8 times their mass here. So the equal sign specifies that I'm going to assign a value to this cell. That value is 9.8 times their mass. So here we have the forces upon them, which is gravity, 980 newtons. And so their acceleration is equal to forces divided by their mass. However, instead of just pointing it at not at B9, I'm going to specify that as B$9. The dollar says when I complete this, when I drag this cell down, I always refer back to 9 instead of incrementing it, because you can't divide by position, and then the next value under position is 2000 is not going to be useful information because of position and not mass. So punch that there. So there's our scoop. Forgot to mention that that's down at minus 9.8. There we go. So there's the minus sign. Okay, next time step. Alright, the next time step is the previous time plus $6. Again, specifying that each time step is going to refer back, each increment in time is going to be back to here. Position. I'm going to use Google Sheets would like to make a suggestion. They're incorrect. So position at the next time step is equal to the previous position, A12, plus their previous speed, That is, oh, nope. 8, nope. Gotta get this right. Position is B11, the previous position, plus their previous speed, that's C11, try again, C11, times the time step, B$6, plus 1/2 times acceleration, E11, times time step B $6 squared. This is our position equation. It's the same thing as x naught plus v naught t plus 1/2 at squared. And so there's the next position. Then we do the same thing for speed. This time we have the previous speed of C11 plus acceleration E11 times the time step of C$6. What are you talking about? Oh, $6 is the wrong one. My apologies. That's B6. B$6. Well, I mean S cannot be converted to number. Oh yes, that is exactly what I mean. This thing right here, that's text and not number. Yep, makes sense. Like, well, hold on. All right, forces. All right, forces. So forces, we still have their weight. So that is still -9.88 times their mass. B$9. And then we're going to minus. Okay, so now we need to be really careful about this. So I'm going to actually add this. If. So now I can insert the function if. And now I can specify a condition. So if, actually I'm going to subtract it off. So minus if, alright, if, now I'm going to specify that if their position, so position is B12, is less than 500 meters, then their sigma is going to refer to, so it's less than, so this is going to be sigma 2, and that is B$8, B$8. Otherwise, it is going to be B$7. So I have an if, I specify a condition, and then I specify the true result and then the false, so if the condition evaluates as true, it will take on the first value. If it evaluates as false, it will take on the second value. So if the person is lower than 500 meters, then they get to have their big sigma, and if they're higher than 500 meters, then they get the small sigma. And then I'm going to multiply by their speed in C12. Yes, that should be it. And this should be smaller because they're coming down, so they have an arrow resistance up, and this should be smaller than that, and it is. Very good. Acceleration. Continue on down, just like that. Now I have essentially programmed my results, everything I need to know about what's going to happen has been programmed. And so now I'm going to loop my program until I get to position is 0. Oh, and of course we're going to have some problems with my interface here. So fine, be like that. gonna say we're probably gonna be at this for a while. How far did we get? All right, we're at 29 seconds. Oh, we went further than I expected. Probably because they are cruising the ground there. Okay. So they hit the ground. We'll go ahead and take this as their answer. Not because it's a safe answer, but because it's, you know, it satisfies. All right. Yeah. So right here. Yep. And then flips over. Yeah. See that jump right there? That's the change in condition from being above 500 meters to below 500 meters. That's probably, yeah, they're still going, their velocity is still increasing, so that is quite unfortunate. But I think it satisfies the purpose of this particular video, indicating that one way to solve this particular answer. So let's see here. So now that I have that, I'm going to, you know, just to make sure that we are being consistent here, to actually get all the way down. Oh, come on. Show me, give me one more time step. There we are. All right. So now I will go ahead and take this, when do they land, and say equals to this time. And how fast are they going? They're moving this fast. Like so. Obviously this is not a happy result for our parachuter. They're going to want to have a word with the designer of their parachute and say, you have failed miserably at this. And I think that is actually going to be enough, because I've shown you the conditional if here. That'll be enough for you to figure yourself out. If you want to, you could use the conditional to set up this here and say something along the lines of, if this value is, if this is less than 0, then 0, otherwise that. You can say something like less than or equal to, and I'll put it in the conditional. And so if it's less than or equal to 0, then it'll return 0. Otherwise, it'll return the position, and it will look like nothing. But now if I drag this down to the bottom, come here, if I can do that, if Sheets will let me. Now I drag all the way down to the bottom, and I can do this and drop it there. And I'll recalculate everything, go, ah yes, here we go, ta-da! And you can do the same thing with velocity if you like, and then if you want to, you can, if you wanted to, you could keep going down, and then over here, you can use the conditionals to return back up to a fixed location your answer. So you can say, if this is equal to 0, then it becomes this. It becomes this value here. Otherwise, it becomes the value below it, and then it'll propagate up to the top. You can say something like, go here, and say equal if position is less than equals 0, then return time over here. Otherwise, return the value below it. And so, it'll return the time at the spot there. if it returns false, then it will return the value that's immediately below it, propagating from below the value of the time all the way back up. And here we have a good autofill suggestion from Sheets. You show a shall hit Control Enter, and it does so. Boink, and there we have it. Not quite the same answer. And so then I can come over here and say this shall be equal to this value here, and have the answer immediately land right here and not have to worry about it. I will take either answer. Both satisfy me as far as I am concerned. So just as long as the programming is sensible. Sensible choices will be accepted whatever the answer is. And so, can't say something like, all right, time step 1, and expect good answers out of this. And so, we're not going to do something like that. So point 1 is much better choices there. So if you want to include, say, a plot of position versus time, where are they? Come on, come down to here, and you scroll back up to the top, just so that your plot is somewhere reasonable, hopefully, and you can insert chart. Come on, insert my chart. Okay, yep, there we go. And so now I have the whole position. It's trying to grab stuff that doesn't make a whole lot of sense. It's like the x-axis, y-axis series. Yep, that makes sense. It's trying to grab values that aren't sensible for location and what have you. But we do have. It's trying to grab stuff that's up here for the series stuff. I find Excel and LibreOffice will probably give more sensible choices for what these values ought to be, rather than try and grab stuff like, what are you doing? So we can, and so there's that. So if you want to, you can make your plots and go, is this sensible? Does this make sense? What have you? When does it deploy? They deploy their parachute at 17.5 seconds. So you can see that. 17.5 is right about here. Not really. Yeah, I don't see any change there. But if you were to say, take acceleration and time, come here, control time, and shift that all the way down. Let's see if it goes with us. We might have to make some choices here. Okay. Right. Okay. It's going to be unhappy with us here. Okay. Let's see if we can do this a little more civilly then. And then I can do that. There we go. And that was, I deselected that with Control. And now I'm going to insert my chart. There we go. And now we can see our acceleration, where they're doing this -10 stuff right here. Mostly minus gravity, with very little air resistance, and then all of a sudden they deploy their parachute right here, and their resistance shoots way up, trying to for that parachute to try to stop them further to the ground. All right, and so that concludes, as far as I'm concerned, my demonstrations of Google Sheets on how to program there with this particular problem.